Hi everyone, my name is Thomas Kim. Today is May 5th, 2023. This is my 64th episode for C++ Electricity and Magnetism, Vector Calculus, Classical Physics. In this episode, we will learn OpenGL texture for the first time. Also, OpenGL texture song. This is our OpenGL texture song. Create textures, bind texture, text stories 2D, text of image 2D, bind texture unit. I will hide it like this. Create textures, bind texture, text stories 2D, text of image 2D, bind texture unit. Create textures, bind texture, text stories 2D, text of image 2D, bind texture unit. If you remember this texture song, you can create cool OpenGL programs. If you want to follow my current session, you have to install updated OpenGL tools. Right before filming this video, I updated these OpenGL tools by watching my previous videos listed here. Especially whose title starts with setup, you have to install updated OpenGL tools listed here. Without further ado, let's get started. Open up Visual Studio Code, Electricity and Magnetism. Select empty space. Click this button, 064 Textures. Click this button, text.cpp. Click this button, text Vertex. Click this button, text Frag. Click this button, resp.txt. Hit enter. Ctrl V. I will close welcome window. Select text.cpp. Include CPG, STD, extensions.hpp. Include OpenGL Programming Guide 9th edition. Begin app I have forgotten. Right click, go to definition. In this file, select vf.h, go to definition. If you scroll down, you can find macro, begin application declaration, copy, paste, texture, app, then end app declaration, define app. This is our class name. Copy, paste it here. Now select response file, resp.txt, icxcl, text.cpp, oi.exe, qsdd, c++20, ehsc, mdd, link, subsystem, console. Copy, paste it here. Namespace, 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 cpt, cpg, types. You have to remember this namespace alias in the response file. You can remove icxcl. Now you have to open this command prompt. You should see Intel SQL OpenGL Programming Guide 9th edition. dir cd 064 textures icxcl at resp.txt. Hit enter. Sorry, I made mistake. Here we have to provide title. Hello OpenGL texture. We will rebuild. CLS it should build and run successfully. Now close it. Right click, begin app declaration. Go to declaration. Right click, Vermilion application. Go to definition. In this class, you can find virtual initialize, copy up to resize, copy, paste it here, public, paste. We will remove virtual, remove all, now override, also override, also override, also override. In this part, glFW, set window size. We will define context per int width 256, context per int height 256. Pass this m window width height. Now program, create program. We have text birth, quote, text birth, quote, text flag. These are our shader program. Copy in the private section glUint program. Now we can close vermilionapp.hpp, OpenGL 9.hpp. Also, response file. I will arrange side by side in the text birth version 460 core. Copy, paste. We will create a very simple shader program. Layout, location 1 in vector v position, void main gl position v position. Very simple vertex shader. Now in the fragment shader, out vector color, void main color vector 1111. This is color white. With this, we will build again. Okay, it built, crashed, close program. Now here we need glUint vertex array object, vertex array object, glUint vertex buffer object, vertex buffer object, enum red, green, blue, alpha. Now in this section, I will sing a song for you. Create vertex arrays, bind the vertex array, enable vertex attribute array, vertex attribute pointer, gl create vertex arrays. 1 vertex array object. Create the vertex arrays, bind the vertex array, gl bind vertex array. We bind this vertex array object. Then I will sing a song for you. It is called buffer song. Create buffers, name the buffer storage, bind buffer to its target, gl create buffers. 1 vertex buffer object. Create buffers, name the buffer storage, gl named buffer storage. Buffer vertex buffer object. Size, well, here context per int size, width, height times components, context per int components for RGBA components. we will create some memory. std vector gl plot positions semicolon negative 0.75 negative 0.75 0.0 f. This is bottom left coordinates. Copy, paste, paste, paste. This should be bottom right coordinates. This is positive. This should be top left. Top left. To be top left, it should be positive. Positive. Then top right. It should be positive. Remove trailing comma. Please understand, our vertices should wind up in the counter clockwise. For example, bottom left, bottom right, top left, top right. Forms counterclockwise orientation. Now here size of GL plot times positions size. Now data positions data. Then GL bit field flags we can set 0. Create buffers, name the buffer storage, bind the buffer to its target. So gl bind buffer. We will use gl array buffer. Buffer should be vertex buffer object. gl array buffer means we are going to feed vertex buffer object for our attribute. vPosition is called vertex attribute. So to pair this vertex attribute, we need to bind gl array buffer. Create the vertex array, bind the vertex array, enable vertex attrib array, vertex attrib pointer, gl enable vertex attrib array. So glu int. This index represent our vertex attribute positions, location. It should be 1. Create the vertex array, bind the vertex array, enable vertex attrib array, vertex attrib pointer, gl vertex attrib pointer. Index. This index represent vertex attributes. Location 1. gl int size. This size means count of components of a vertex. 3 plots forms 1 vertex, so it should be 3. Then type. Its type is gl plot. Of course, it should be gl plot. Then normalize. When we are using floating point numbers, we simply pass gl pulse. Then stride 0. This gl void pointer is offset, so we pass null. Now in the function display gl use program, we have to select our program. Static const gl plot black. This is color black. So 0, 0, 0, 0. 4 elements. gl clear buffer FB, GL color draw buffer, default is 0, pointer black. Now GL draw arrays, GL triangle fan. Count, we have 4 vertices, so it should be first should be 0, count should be 4, because we have 4 vertices. With this, we rebuild CLS I. Something wrong. Close program. We forgot one thing very important. We have to call base initialize title. Don't miss calling this function. With this, we rebuild CLS I. We have this pretty square. Now close it. Don't forget calling base initialize. In this part, I made simple mistake. Bottom left, bottom right, top right, top left. It should be also fixed. Bottom right, top left from the counterclockwise orientation. Don't forget this part. When you form geometry, your vertices should wind up in the counterclockwise orientation. Now, in the private section, void generate bitmap. It should be template int width, int height. Now here GL plot. This should be height. This should be width. This should be 4. This is array. Array cannot be copied. It should be reference data. Now for int y 0, y less than height plus y. For int x 0, x less than width plus x. I will make it bigger. Data y x red, x and y and 0x ff. We use some bitwise operation. It should be plot over plot 255.0. Copy, paste. This is green. We will use bitwise OR operation. I will arrange like this. It should be blue. It should be alpha. It is bitwise XOR. I will set alpha 1.0 F opaque. Now scroll down. In this section, std vector gl plot host bitmap. In this case, we defined size. We pass size element. Allocate dynamic array or size elements. Or it should be L-value reference array. We can use typecast. For example, reinterpret cast GL plot. It should be height. It should be width. It should be components. I should use lower case. Then host bitmap data. So this is pointer. This is array. We have to convert to pointer. Then the reference. Why is squiggle? This is very ugly. Now we can call this function like this. Array. Wow. std cout array std, and there. We try. We rebuild. cls Wow. I will close it. Huge numbers. cls. This is very scary. So I will disable. Instead, auto array cpt cast pointer to array. We pass height, width, components, then host bitmap data. This function, right click, go to definition, is defined here. The same. Okay. Now we can close it. I will disable this part. Now we need OpenGL texture song. 산 토끼 토끼야. Create textures, bind texture, text stories 2D, text of image 2D, bind texture unit, create textures, bind texture, text stories 2D, text of image 2D, bind texture unit. So we have to create texture. GL create textures. Target. This target should be GL texture 2D because we create two-dimensional image. Then size 1 texture 2D. Scroll up in the private section. glUint texture 2D. glUint texture buffer. Of course, we can initialize. Scroll down. We created texture. Then bind texture. bind texture. We use glTexture 2D texture 2D. We create buffer. create buffers. 1 texture buffer. We have to bind texture. bind buffer. We use glTexture buffer. Texture buffer. Now create textures, bind texture, text stories 2D, text stories 2D, target. Target should be glTexture 2D, size level. This is min-map level. We can put 1 or 8. Then internal format RGBA32F. Then width, then height. Text of image 2D. text of image 2D. Target glTexture 2D level, I will use zeros level offset 0, y offset 0, width, height, format, glRGBA. Please note that this is format. This is internal format. They are different. Don't get confused. Then type glFloat. Then pixel. Pixel is host bitmap data. Please understand, we created host bitmap here using generate bitmap. Then we pass this host bitmap's data pointer. See the pop-up window glFloat pointer. Now create textures, BindTexture, text stories 2D, text of image 2D, BindTextureUnit, GL, BindTextureUnit. So, unit texture. In the fragment shader layout binding, we can pass any number. I will set 2. Uniform sampler2D, sampler2D, semicolon. BindTextureUnit is this binding point 2. For our sampler2D, its binding point is 2. So we pass 2. Then texture. Our texture is texture2D. Now in the function display, everything is ready. In this part, back to texture size. We use function texture size. We pass our sampler 2D. This is level 0 because we use, in this case, this is level. This level should match with this level. Then back to texture position. GL flag coordinate XY over texture size. Here I will disable it. Copy, paste. Now we use texture function. Again, from sampler2D, we pass texture position. With this, we build again. CLS I. Wow, beautiful. Beautiful. Tokiya, create textures, BindTexture, text stories 2D, text of image 2D, BindTextureUnit, create textures, BindTexture, text stories 2D, text of image 2D, BindTextureUnit, create textures, BindTexture, text stories 2D, text of image 2D, BindTextureUnit, create textures, BindTexture, text stories 2D, text of image 2D, BindTextureUnit.